Hello again and welcome back. I'm John Ball, the founder and CTO of Pat Inc. And today, as we arrive at the end of 2022, I want to review what we can do in 2023 to improve on the theory of natural language understanding and therefore for AI, because in my opinion, natural language understanding is the key human element that makes AI and makes humans intelligent. So let's go through in a bit of detail what this 2023 challenge is. So what we've done is we've looked at three very simple theoretical problems that need to be fixed in order for NLU to work. The first one we look at is a challenge where you take a couple of sentences, you break them into their structure, and it's up to you as a theoretician how you break that into structure, presumably using parts of speech or some other grammatical elements. And on the basis of that, you can then continue with your NLU approach. What I'm going to put into the problem, though, that you have to solve is two sequences which are alike in parts of speech, but one works, one doesn't work. One is grammatical, one's not grammatical in English, or one is meaningful, the other is meaningless in English. That's the first test. The second test, we're going to look at large language models and give a challenge for them. If you consider what people do with language, like when you're buying things, you have this requirement to recognize who's doing what to whom. What are the elements you're buying? Who's the one buying it? How much is being spent, and so on. So we're going to have a couple of sentences where you need to be able to interchange with generalization on those two sentences so that you can answer questions. And then the third one is just reviewing what was it in the 1950s in Chomsky's famous syntactic structures, and around that time, what were the key elements that resulted in the study of grammatical structures independently to meaning. So our goal today is to look at those three things. So let's progress. Okay, so as I've said, this discussion today is about the 2023 breakthrough, the challenge for NLU. Let me just move that out of the way. That's a bit annoying. Okay. So here's the first test. Structure should be bidirectional. If you say something, whatever the meaning is that you say should be the understanding that you've got. We should have the same meaning as we have words, and words should convert back to the same meaning in the person that's hearing it. You need context to make that work correctly. But here's the problem for you. Here's test one. If we start with, and this is using traditional grammatical elements, a noun phrase of a noun phrase by a noun phrase is an adverb. There's two samples there. The buying of cars by the dealer is today. That's the first example. And that's basically a predicate phrase, the buying of cars. It's about buying. So the head of that noun phrase in the old terminology is this predicate of buying. And because it's a predicate of buying, you can ground it in time and space. So the buying of the car is today. Equally, we could say the buying of the cars by the dealer is in the car park. You can ground it in time and space. But if we have a look at the next example, that's a referent phrase. It's about a cup. It's about the lip of a cup. So in that reference phrase, we call them reference phrases because that can actually be more complex. It can also, the top one's a reference phrase in role and reference grammar. But the lip of the cup by the dealer is today. Now, how can a cup be today? What does that even mean? So the second one doesn't make any sense, but the first one does, but it's the same structure. So the challenge is, if we're going to use the same structure as the basis of the language, if we're saying this is grammatical in the language, and then you can substitute in words that are grammatical and you can substitute other words in that aren't grammatical, there's a problem with that. It's not bidirectional, it's not a consistent model. So I want your explanation for how you can make that work for these types of analytical models. The second test is for large language models or for any type of word vector type implementations where you're saying you're just going to look at the statistics of words. You can have a transformer, or you could have, Elmo, or any of those type of word vector models. And you need to work out how the arguments are connected and how the generalization works, right? So I'm making this quite difficult because generalization in these cases isn't particularly easy to do. And why? Because the whole concept of a word vector is you have this sequence of letters, and that sequence of letters is then in this vector space. So in this example here, you can see in the green, the sale of the car to the buyer by the dealer was completed. A good English sentence, easy to understand. But the main predicate of that transaction is sale. It's about selling. It's a noun that's discussing the predicate selling. And in the second one, we've got the dealer completed buying the car from the buyer. And so buying isn't selling. It's not the same word, but we understand that there's a transfer of goods when you buy that's very similar to the transfer of goods when you sell. There's some subtle distinctions there, but a normal human being that speaks English with probably an intelligence of 8-year-old or something would probably understand this sentence. If the dealer completed buying the car from the buyer, you can then ask questions like who bought it or who sold it, and a child would understand that. So we want an LLM to be able to manipulate these phrases, these arguments of the predicate, in the first case, the predicate of sell, with its arguments, and the predicate of buy in the second one with its arguments, and then be able to align the fact that selling and buying are two predicates that are the same, really. And you need to use your word vectors to accurately map those types of sentences together. And then the third test is just going back in history to this very famous sentence, because it's really the fundamental reason why people are happy to say that we need to solve grammar first and then we'll worry about incorporating meaning and context. And that's the model that really went solidly from the 1960s through to the 1990s, 30 years of work, and it never actually resulted in a parser that could understand any human language. Certainly not English, but no human language has ever succumbed to the impressive human intellect that's gone into building a parser with all of the different ways of doing it. We can actually do it these days with role and reference grammar and pattern theory, which is one of the reasons we're putting this challenge out, because we have a scientific solution for something that's otherwise unsolved. So when you look at this model, and this has come from Wikipedia, this particular image as well, so credit to the wiki page for that particular sentence, you can see the sequence is adjective, adjective, noun, verb, adverb. What that is telling us is that that's an English sentence. And if it's an English sentence and you're going to the trouble of creating a parser that can recognize these English sentences, it should always be grammatical, right? Because that was the whole test, is this a grammatical sentence or not? And so here, old yellow flags wave furiously. Looks like a perfectly valid English sentence. But we can substitute adjectives and nouns in this next sentence, which is the famous Chomskyan one: colorless green ideas sleep furiously. And that sentence, while it looks grammatical, it's not using what are called these aselectional restrictions. So predicates determine arguments. The selectional restriction says this predicate allows this type of argument. And you can't be colorless and green, and you can't be a green idea because ideas don't have any shape. They're abstract. Ideas can't sleep because ideas aren't animated. They're not animals. And you can't sleep furiously because that's not how sleeping works. So because that sentence has a zero probability of existing, the argument was, well, because we understand it, that means there's this syntactic model underpinning all of human language. Pattern theory says there's a pattern matching model underpinning all of language, and the various languages of the world really reinforce that model, that as long as you can recognize the pattern in a human brain, you can then speak a language with it. And then the last one, I'm going to substitute in exactly the same parts of speech. Running, 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 runs furiously. And to me, that's gobbledygook. That's not English. Well, I mean, I recognize the words. But running, 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 runs furiously. What is that even talking? What's a running, running? I can't recognize it in my head. I'm a native English speaker, and my point is that if you can't recognize that, there's something fundamentally wrong about this whole approach of working out grammatical elements independently to meaning. And I think that's that's the main point that I wanted to make, that we need to test theory to explain the things that we can see. If you can go to all this trouble of parsing sentences and the resulting sentence is both grammatical, ungrammatical, and completely meaningless, that's not a great model to work with. And plus, as we know, back from the 1980s, when DARPA funding MIT and various other groups got together and worked out, we can't even work this out in real time because it's an NP-hard problem. So the point is, there's the challenge for 2023. I'd like people to get out there, and if you're a deep learning enthusiast or you want to see these large language models get to the next step, tell me how you can do that second test. If you're saying we need to go back to the previous models that didn't work for those 30 years, tell me how you can solve that first problem of working independently to meaning and context in order to solve these particular problems. And I think at the end of it, what you're going to come to the conclusion of is that role and reference grammar and pattern theory really holds the key to the next big paradigm for natural language understanding. So there we have it. Thank you very much for your time. There's a companion Medium article that goes with this YouTube video. Please read that. I look forward to your comments and how we can go forward into 2023 with a good solution to NLU, which builds on these basic premises into a proper scientific theory for understanding language. Bye for now.